the homework from last night? Yes. Weird? Yeah. Shh, Brett, come on. 37. All right, so I'm asked to solve algebraically and confirm graphically. So I have x plus 1 minus 2 root x plus 4 equals 0. So what I want to do is isolate that radical first. So I'm going to move these two to this side. So it leaves me with negative 2 root x plus 4 equals negative x minus 1. Yes? Say again? That's what we're going to do next. So we're going to divide this. So what I'm at? Yes. Because your whole goal is to get the radical by itself. Okay. So I've got x plus 4 equals, this would be 1/2 x plus 1/2. So I divided both of them by 2.
I kept it all together.
That's fine. Y'all okay there?
Wait, why is it plus 1/2?
Because it was negative divided by negative. So I just split this up into these two fractions. So x over 2 is the same thing, Brett, as 1/2 x. Right? So now I'm going to square both sides. I square and I square. And on the right side, it's a FOIL situation. So I have x plus 4 equals 1/2 x plus 1/2. 1/2 x plus 1/2. And I'm going to FOIL this out. One-fourth x squared y'all know I'm ADD. I forgot to tell you also that part of the remediation and earning the mastery points, you have to have completed all your assignments, same as last year. So you can't have any zeros for homework and get the remediation. I think that's only fair. Anyway, that thought just popped in my head. So I have x plus 4 equals 1/4 x squared plus, what's a fourth? 1/2. Make it equal 0. Go with me. Subtract the 4 and subtract the x. And what I might do before this, I might do that LCD thing before I do this, looking at it. I might go through and multiply everything by 4 to get rid of all these fractions, because I'm going to be in a quadratic situation. I may have to factor, I may have to use quadratic formula, I may complete the square, but I'm not going to want fractions when I do that. So I'm going to take this 4 to everything. I'm going to do 4 plus 16 equals x squared. Half of 4 is 2, and 1/4 of 4 is 1. Does that confuse anybody? Okay. I just wanted to get rid of the fractions.
Okay. How does, I don't understand how that cancels out fractions.
Well, what is 1/4 times 4?
Oh, okay. Okay.
Minus 4x minus 16. So now I have 0 equals x squared minus 2x minus 15. Now I can say, okay, can I factor? Does anything multiply to negative 15 but add to negative 2? Negative 5 and 3. This is an easy factor since there's a 1 in front. I can do the shortcut. Negative 5, positive 3. What are my solutions? 5 and negative 3. I forgot to click what? Oh. Ah. Try now. The shortcut is when the leading coefficient is 1, A times C is just going to be whatever that last one is, and whatever those two factors are that multiply to negative 15 but add to negative 2, that's what just goes here with X. You don't have to slash it. As long as this is a 1. Yes. It won't let you? Yeah, you'd move it to the other side. Then I would be in the situation of having to do quadratic formula, complete the square, graph and find the zeros, some other type of did I not do it as a okay. Okay. Let me try again. All right, Charlesy, try now. It's down below it, but I can't move it until I get out of tablet mode. All right, couple more questions. Yes. 40. 38. All right, 38. Okay, yep. All right, 39. All right, so you could do this one of two ways, guys. It says to solve graphically by converting it to an equivalent equation with 0 on the right-hand side and then finding the x-intercept. So if you did it that way, I mean, technically that's what it told you to do. If you just graph this as two separate functions and found the intersection point, that is okay too. Yeah. Okay, then let's do that. Let's move. So I would move this one because it's only one thing to move. I would say 2x minus 5 minus square root of x plus 4 equals 0. Graph this. So 4. Yes, that's all you were supposed to do. Y'all didn't read the directions?
Yeah, I did too. Like, I want you to solve it. I'm just trying to break it down a little bit.
3.906 is the answer.
You wrote the paper, you wrote the answer on there, but I mean, I tried to do the answers to algebra.
You don't have to do this one algebraic. None of these are algebraic. The only algebraic ones were up through 38, but I will do 38, yes. Oh. It's in your notes. We did it in the lesson yesterday. What's wrong? Just move it and make it equal 0.
Miss McGee, your board's going into standby.
Thank you, Ethan.
I don't think you heard us say it like
I got it. Okay. Other. No, not really. He makes you be quiet and pay attention.
Well, actually, we're making we're actually trying to find like a real something that we're actually trying to find a number that actually means something. And here we're just finding a bunch of random numbers that have no significance whatsoever. So like it's kind of like.
Thank you. Got it. Okay. Yeah, that was not offensive at all. Thank you. Appreciate it. Other questions about your homework? Does that answer your question? Make you feel better about that section that you just make it equal? Okay. Okay, so 40. 40 is the absolute value of 3x minus 2. And I'm just going to subtract that whole chunk from the right side. So it's 2 square root, oops. $2.864. Oh, and negative 1.086. Second trace. Oh, you're talking about how you type it in the calculator? All right, the absolute value. Okay, hit math. Scroll over 1 to NUM for num, number. And the very first option is ABS for absolute value. You're welcome. Yeah, no, just close the parentheses. Well, no wonder y'all came in struggling. Because these were terrible to work out by hand. Some of them, yes, but you have to set it equal to a positive, set it equal to a negative, and then you've also got the quadrant. It's awful. Did you do it by hand too? Y'all, I failed yesterday as a teacher, clearly. I'm sure you're excited to hear that because my calculus kids were up until 2 in the morning doing their homework struggling, and y'all struggle on your homework. I'm sure you weren't up until 2 doing it, though. So I apologize for this, right? Because well, normally somebody will text me and say something's going on with this homework. I don't understand, but no, I didn't hear a peep out of y'all yesterday. Okay, yeah, 1 a.m. Okay, so I'm going to start this lesson. I'm going to do this lesson a little bit differently. And let's see if this helps you out a little bit more. I hate this book. And we're getting new books, but they're still not here. So I think what I'm going to do is I'm going to teach you from the homework problems instead of from the... Anyway, you don't need to know. You just need to know we're doing notes. And hopefully it'll go better today than what it did. So you'll have odds for homework. I'll be doing even examples as we go. That way your notes line up the work that you will be doing. So I'll give you just a second to switch gears, put your homework up. I was fixing to ask if it was Nord.
He was like, we don't even have a grade of that class right now. He was like,
Hate is a wrong word. Let's not use it. That's not nice. This should be, you will find that this whole first chapter as we're going through pre-calculus is a lot of what you've had in Algebra 2. We're just going a little bit deeper with the Brett. What makes something a function? In other words, tell me the definition of a function. Okay, more specifically. What makes it a function, though? Yes, Abby. There you go. Every input only has one output. You can't have the same x value for multiple different y's. Okay, so that x can't repeat itself. So one and only one output for each input. Now, think about what that means. Graphically, you learned a way to look at the graph and tell if it was a function or not. What was that?
Vertical line test.
I think. All right, the vertical line test tells us whether or not it is a function, because if it hits more than one time, it's not a function, because if I drop the vertical line right here, that's right, this particular x value, this might be like 2, 5, and maybe this is 2, -5. It's got two different outputs for the same input there, and it fails. So this is a fail. Everybody okay on recognizing? Okay, thank you for your opinion. They hit the same. Yes, yes. Right, right. If I did this, it passes, right? There's no place you could drop a vertical line and it would hit more than one time. Yes, not a function in a function. All right, so for example, direction of this problem says, determine whether the formula determines y as a function of x. If not, explain why. That's a plus or minus. Is that a function, yes or no? I hear no. Why? Oh, okay. What does this look like? All right, x squared plus 3. Okay, that's your parent quadratic graph, but what's been done to it? Up 3. It's been shifted up 3. There's x squared plus 3. What's x squared minus 3 look like? Is that a function? No. Why is it not a function? Correct. It's both of them. Yep, it's both of them. It's both of them. No. Oh my gosh. I think we read too long.
I love reading.
How about is y a function of x? Yes or no? Sure, you can move it around if you need to. Yes, it is. Why? right? 12 minus x. This is just a line with a negative slope, right? One more example. I'm doing, by the way, these examples are coming from the even numbers of the sets of your homework that you'll do the odds on. That way your homework and the examples we do in class parallel. Hopefully that makes it, yeah. What about functionality so far, Brett? All right, function or no?
I can't tell because it might have been a drawing error.
It is you can tell what this is supposed to be. This is, there's an asymptote here. Yes, this is a function. Yes, this is a function. Huh? No, it didn't have an equation, just graph. Let's talk about domain and range. Stop. All right. Tell me some things that restrict domain if I am looking at, first of all, what is domain? I guess I should say that. Let me make sure we understand. The X. Domain describes X, right? If you are simply given the equation, how do you determine domain without graphing? What are you looking for? Two big things you're looking for, huh? Any kind of equation. What would restrict the domain? What would keep us from having certain values in the domain? All right, we can't divide by 0. Anytime we divide by 0, that's undefined. So if your equation will lead you to dividing by 0, you have to leave those values out of the domain. Do y'all remember when we talked about this? Some of you said.
I'm being honest. I remember doing domain and range.
Okay, let me show you an example. If I have h of x equals 5 over x minus 3. That bottom can never be 0. Do you agree? Okay. If it can never be 0, what is the value that would cause it to be 0? Positive 3. We all agree with that, right? So x cannot be positive 3. All in agreement? But it can be anything else, right? If you put positive 3 in this equation, you would have 3 minus 3, you would have 5 over 0, and we cannot have 5 over 0. It could be 4, sure. It could be 3.99999. It cannot be, or 2.99999. It cannot be 3. Anything but 3. So how would we write that? How do we leave a single value out of every single number in the whole world? Let's do interval notation. Okay, if I leave a single value out, let's think about it on a number line first. I need everything except for 3. Gosh, dog. So open circle, but open circle is the same thing in interval notation as parentheses, right? So I want to come from negative infinity all the way up until I hit negative 3 and then I stop, but I don't include it. But I can pick up on the other side of negative 3 or positive 3 and include all of these values. So the way I leave a single value out is I say from negative infinity to 3 with a u, that's right. From 3 to infinity. It's exclusive. It does not include 3. So to leave a single value out, back-to-back parentheses. Yes.
Can you do another like
Yes.
type of equation?
Yes.
Or
Yes.
that's the only way you can-
There's 2 situations that we're looking for. The first, we're looking for dividing by 0. Okay. If you divide by 0, you have to leave out the value that causes a 0. So if you set it equal to 0, it'll tell you the value, but yes, you just take it out of the domain. It cannot be in the domain. So for this function, the domain would be negative infinity to 3. No, you got a fly. I see it. All right, let's do another one and let's look. Look at this one. Okay. For domain, x cannot, remember I'm looking at fractions first, and then we'll talk about the other scenario. The bottom can't be 0. What values of x would cause the denominator in one or both of these, this time I got 2 fractions, to be 0? So we all agree that here x cannot be 0, and here x cannot be 3. Do you agree? How can I write that? How can I write the domain for this to leave out both of those values now? Twice. All right, so I'm going to go from negative infinity. I'm going to truck up the number line. Whenever I hit 0, I stop, right? So stop. I'm going to do the back-to-back parentheses at 0 because that's what I'm leaving out. And then I go up to what? To 3. I stop again to leave 3 out, and then I keep going forever.
These are all like they're not fractions. Oh yeah.
No, because I'm leaving them out. That's exactly right. Everybody okay there? Can't be that number. Right. I told you. What time is the bell ring? 25? 11:15. Let me just get through domain and range and I'll stop because we're way behind. Okay. I told you there was 2 scenarios with domain and that was one of them. The other scenario, so this would be number 2 under there, is a radical situation. Why might a radical be a certain situation? You can't have a negative under the radical. If I have a negative under the radical, I end up in an imaginary world, right? That's when my imaginary numbers come into play. So never negative. So I'm going to do the same kind of thing. I'm going to look at what might cause it to be negative, and that's what I don't want. Okay. Or maybe I look at what keeps it positive. So for example, let's say I have what is the domain? And I just put a little note there. Take what's under the radical and set it greater than or equal to 0. Okay, so that I can determine. So here, if I need this to stay positive, that means I need it to stay greater than or equal to 0.
Put the square and the square just gives that one.
Not in that case. Remember, you're adding or subtracting. Those rules aren't the same. If you're multiplying, yes. Huh? Is what we do. Everything under there has to stay positive. So you're going to have to solve this for x. So divide by negative. What happens when you divide by a negative? The sign flips. Now what? But let's think about this for just a second. I've got a plus or a minus, right? If I have got to stay smaller, here's negative 2 and here's 2. Yeah, square root. Let's plug some values in and see what happens. What's in between negative 2 and 2? 0. If you put 0 in this equation, am I still positive? Yeah. If I put 1 in this equation, am I still positive? Yes. So I need all these numbers smaller than here. So I need to take the positive instead of plus or minus. See what I did, how I reasoned through it there to see, make sure? Okay. This says plus or minus 2, right? So I'm wondering if I do this, it's a little redundant, right? Smaller than negative 2, because everything smaller than negative 2 is also smaller than 2. So my question is, do I need to include these numbers or not? Will they satisfy the equation?
Oh wait, so it can't.
They do satisfy. It can be what?
It can be positive and it can't be negative.
No, but could it be in between? Sure, it works in between. So I'm just say x has got to be less than or equal to 2. And it can be, Kirsten, it can be 2 because it could be 0. That would make it 0 in the middle. I mean, in the radical. So how do I write that in interval notation? I'm fixing to make this a little bit harder. That includes negative 2. Negative 2 is in that range, right?
Yeah, but I thought we had to stop at negative 2. Negative 2 becomes positive 3.
Oh, you're right. I need to go this way with it. I'm sorry. Because look, what happens if you do negative 3? Plug it in there. What happens? Needs to be, I know. I'm sorry. I know I'm almost out of time and I'm rushing. Yes, because it's got to stay between those two, but it can't go outside. Yeah. They're both brackets.
Okay, so basically
all right.
when we solve that answer,
it's going to be between those two values. Correct. Now, you're going to have to do range. We talked extensively about range. I'm going to assume you can do range. Range, you're going to graph. You're going to look at it on the calculator and do the range. Ethan, stop. Okay. Now, what happens if this is not just square root of 4 minus x squared, but it's minus x squared over x minus 3? The bottom is going to be 0, which means that x, in addition to this being between negative 2 and 2, this can't be 3. But is 3 even in there? No. So it's a moot point. Doesn't matter. This still satisfies the domain, even if that's in the bottom. If you need to do it separately, yes. If it was in there, is that what you're fixing to ask? Let's say I set up a domain and I found out that 0 did not work. I would back-to-back parentheses here. So I would be negative 2 to 0, 0 to 2. That's positive. All right, for the range, what you're going to do is you're going to look on your calculator, okay, and you're going to analyze the range there. So if I have something, I still got 5 minutes. If I've got something that looks like this, let me see what kind of graphs you're going to have. Something that looks like this. what is the range of that graph? Negative infinity to 0.
Good morning, Camden High School. Please stand and join me for the pledge.